In this session, I am going to introduce shadow dome. We can't think of a shadow dome like a dome within another dome. That's why it's challenging to locate an element inside of a shadow dome. Dome stands for Document Object Model, which represents the HTML nodes in a tree format. The purpose is to define properties, define a structure, and define contents of a web page. When it comes to a shadow dome, it allows a developer to hide the dome by attaching it to a tree within the original dome. Let me show you how a developer can hide the dome. On this popular books page, we can inspect the search field. Notice above this highlighted section, we see shadow roots 4 times. However, this breadcrumb gives us a clue that the search field element is in a shadow dome, but we only need one of these shadow roots. Do you see hashtag shadow root? That is the only shadow root with an expanded node. The other shadow roots are not relevant and not used for locating the search field. I found this diagram on the internet, and it shows the shadow root structure. We have one original dome and 3 shadow domes. The original dome has an orange shadow host. A shadow host is an element with a shadow tree. The shadow tree is a dome tree, but that shadow dome tree always begins with a shadow root, which is similar to the original dome, which always begins with HTML. It has its own dome tree with elements and a possible shadow host. Do you see how the second box, which is the first shadow dome, has an extension from the shadow host? It has 2 more shadow roots. We are not able to locate no elements in the gray boxes because the developers chose to hide those elements within the shadow dome. However, we can locate the shadow host in the original dome. For example, if I go back to our AUT, we see book app is the shadow host in the original dome. Therefore, it's no problem finding the shadow host. Search by writing 2/ book-app. And bingo, we found the element because it's located in the dome. It's located yellow in the dome. Whenever we see shadow roots, that means it is the start of a new shadow dome. So watch what happens when I search for app header by writing 2/ app-header. It's no good. It's no good because the shadow dome hid the app header element. It also hides the app toolbar element and the book input decorator element. And I can show you that also. App-toolbar. Did not find it. And also look for book input-decorator, and it did not find it. From this diagram, we see how an element can be in one shadow dome or within a nested shadow dome. A nested shadow dome is when a shadow dome is located in another shadow dome, something like the last 2 boxes. There are different ways to find an element inside a shadow dome. We can find an element without using Selenium find element method. Also locate an element when using Selenium find element method. I'm going to show you both ways and demo how to locate an element within a nested shadow dome. And I will see you in the next session. Thank you. In this session, we're going to start by locating an element in the shadow dome without using Selenium find element method. I am going to use the same book application from our introduction and find this search field. Inspect. We are not able to locate this search field from the Elements tab because the search field is in a shadow DOM. Do you see how the ID attribute has a value of input? If this were in the original DOM, we could use XPath or CSS selector to find this element. For CSS selector, start with the tag name input, then ID, and the value input. Did not find it. Remove the input tag, and still no success. For XPath, we write 2 forward slashes, input, 2 brackets, at ID equal 2 single quotes with input inside the quotes. And once again, we're not able to find the search field. In our diagram, the search field would be an element in the first shadow DOM. Now, let's write our code to find the search field. The setup method is pre-written for Chrome, and it loads the book application. The teardown method is commented out to quit the driver. Our method is at test. Make sure it goes to test ng. Yes, at test, public, void, find shadow DOM without Selenium find element. We have 3 steps to find an element in the shadow DOM. First, we provide access. My typing and spelling not going good so far. Provide access so the driver can execute JavaScript. Second is to execute JavaScript. 2, return a web element. Third, we perform an action on the web element. There it is. JavaScript executor is an interface with JS executor as the reference. JavaScript executor indicates that a driver can execute JavaScript, providing access to the mechanism. So we convert to JavaScript executor from the driver. At this point, the driver has access to execute JavaScript. Now that we have access, the JS executor will execute the script. The execute script method executes JavaScript. I want you to notice 2 things in this IntelliSense. Number 1, within the script, we use document to refer to the current document. And number 2, if the script has a return value, then the following steps will be taken. Our test would return an HTML element. So this method returns a web element. To sum up the information from IntelliSense, our execute script method will return a web element and use document. Since the script returns a web element, we cast web element, then assign it to web element with the name like book search field. Let me bring this line to the next line so we can have it all on one page. To complete this script, we need the path from JavaScript. Go back to our AUT, and I'm going to show you 2 more ways for finding this path. But for now, let's just keep it simple, and we right-click. Select copy, copy JS path. That's it. go back to our code and paste the script. It's kind of like cheating a little bit, but this is the path for our book search field, and the script returns a web element. Document represents our web page. Query selector allows us to find the book app element using CSS selector. Shadow root is a property representing the shadow root element. Finally, we have the query selector to find the search field element using CSS selector hashtag input. Last step is to perform an action on the web elements by writing book search field dot send keys, and the keys we send is shadow DOM without find element. Let's run. Bingo. In the search field, we see shadow DOM without find element. That's it. And thanks for watching. And I will see you in the next session where we talk about locating the element using Selenium find elements method. And thanks for watching. Locating an element using Selenium's find elements method requires us to walk through the DOM step by step. For an illustration using our diagram, we are going to find the shadow host, then locate each element in the shadow tree. From the previous session, our setup method controlled Chrome and loaded our book application. In this session, we will use the same setup, and the test script will be @test public void find shadow DOM with Selenium find element. We are going to find all of the statements into 3 statements. We're going to group all of the statements into 3 statements, starting with number 1, find shadow host. Number 2, execute JavaScript to return the shadow root. Number 3, find the web elements, then perform an action on the web element. The shadow host is a web element, so we write web element shadow host. Now we have to find the element. Recall from the diagram, the shadow host comes before the shadow tree, and a shadow tree is a tree in the shadow DOM. All shadow trees begin with a shadow root. Go to our AUT, inspect the search field. We see book app comes before shadow root. Therefore, our code will be driver dot find element by tag name with the value of book hyphen app. We have 2 statements for JavaScript to return the shadow root. The first statement is to cast JavaScript executor from the driver, then assign it to JavaScript executor with any reference name like JS executor. The next statement will cast web element and use JS executor to execute JavaScript. We execute JavaScript with 2 parameters: return arguments of 0, shadow root, and shadow host. The first parameter returns the first argument representing the shadow root element. Notice the second parameter is shadow host. We need the shadow host to access the web element shadow root. The shadow root is located inside of the shadow host. Now we can use the shadow root for the web element app underscore header. Go back to our AUT and we see app header is below shadow root. For our code, each web element will build on top of the previous web elements. We're going to use shadow root and the app header tag name. Shadow root dot find element by tag name, and the tag name is app hyphen header. The next element is app toolbar, but there are two tag names with the same name, so we must identify the element using the class name, which is toolbar hyphen bottom. Just like the last statement, we build on the current element using the previous element, so we use app header and toolbar hyphen bottom. Web element app underscore tool bar. Equal the previous web element, which is app header dot find element. There it is. By. At this point, we can find the element by Selenium locator's class name or CSS selector. Class name would be toolbar hyphen bottom, but let's use CSS selector. And we just add a dot in front of toolbar hyphen bottom. The next tag is book input decorator, then the book search field, which has an ID value of input. We're going to build on top of app toolbar, then find book input decorator, followed by the search field. So the web element will be web element book underscore input underscore decorator equal app header. App toolbar, I apologize, app toolbar dot find element by, let me go back, by. If we wanted to, we can combine the book input decorator element with the search field using CSS selector. The value would be both tag names, which is book hyphen input hyphen decorator angle bracket input. However, let's break it down and use only the tag name for book input decorator. There it is. Now we at the last element, which is the web element for search field. And we're going to use the book input decorator to find the element by ID. And that value was input. Now that we have found the element, let's perform an action on the web element by writing search field dot send keys. And the keys will be shadow dome width find element. Let's run. Bingo. We see the search field show Shadow DOM with Find Element. Thanks for watching, and I will see you in the next session where I will show nested shadow domes. And thank you again. In this session, we're going to find an element in a nested shadow dome. The previous two sessions showed different ways of finding an element. We found an element using Selenium's Find Elements method and without the Find Elements method. I am going to locate the nested shadow dome element using a JavaScript expression. A nested shadow dome is when the shadow dome is located inside of another shadow dome. For example, in this diagram, we see the last two gray boxes are extended from the first gray box. The first gray box is a shadow dome and has a shadow host. It splits into more shadow domes. For our code, it is set up to use Chrome, maximize the window, and to load the application. For our test, it starts with @test annotation, public void find element in nested shadow dome. There will be two main steps. First step is to provide access to JavaScript. And second is find the web element so we can perform an action. The JavaScript executor interface indicates a driver can execute JavaScript. Therefore, we cast it, then assign it to JavaScript executor with the reference JS executor. Now we must find the web element. Let's go to our AUT. It's a shop website for men and ladies. It has 4 Shop Now buttons, and each Shop Now button is located inside of a nested shadow dome. We're going to click the Shop Now button for men's t-shirts. Inspect the Shop Now button. A fast indicator that the element is in a shadow dome is by looking at the breadcrumb. We see shadow root. However, it's a nested shadow dome because we see shadow root 2 times. The complete structure is too big for this screen. Do you see how some of the nodes are collapsed and we are still not able to see both shadow hosts, both shadow domes or element in one layout? I removed the unnecessary nodes so we can focus on the elements for our test script. All of the expanded nodes are highlighted, green, red, or gray. Recall from the introduction, a shadow host is an element with a shadow tree. In this diagram, both shadow hosts are green. The shadow dome begins with a shadow root, which is highlighted red. Our nested shadow dome is the second shadow root. Then we see the button element starting with an A tag. Just like in the second session, we can copy the JS path by right-clicking, copy, then copy JS path. However, in this session, we're going to create the JavaScript path step by step. Go to the console and clear the console. Know what? I'm going to go ahead and paste it, then hit enter. The JavaScript path starts with document.query selector and a CSS selector value. This means the element matching body angle bracket shop-app will be returned. So if I type document dot query selector and the CSS selector within the parentheses shop-app, we see the next output has shop app as the tag name. Notice two things about the path I wrote compared to the path that was copied from Elements tab. My path has single quotes and only shop-app as the CSS selector value. The copied path has double quotes and body angle bracket shop-app as the CSS selector nested values. Either way is okay. I chose to bypass the body node. If we expand each node, then all of the subsequent nodes would make this here look exactly like the Elements tab. I'm going to collapse the node and then go back to the console, to the diagram. And we see shop app is the shadow host and comes after body. Next is the shadow root, which lets us know we are at the shadow DOM. Within the first shadow DOM is the iron pages tag, followed by the second shadow host shop home. That's all we need for the first shadow DOM. For CSS selector, we can skip iron pages and go directly to shop home. In the console, hit the up arrow button. Let me go back to the console and we can click the up arrow. And the up arrow shows the previous statement. To access the shadow root, we write dot shadow root dot query selector. Within the parentheses, I'm going to add shop-home. Bingo. Shadow root represents the shadow root element and is the root for this component. Query selector works inside of the shadow tree. Do you see how we're walking through the DOM step by step? In the diagram, we're at the nested shadow DOM level and it's the same process. For the Shop Now button, I am going to get the shadow root, bypass the div tag, then return the shop button and the element which starts with the A tag. In the console, we write dot shadow root dot query selector. Inside the parentheses, I'm going to write shop button angle bracket A. Bingo. Here's the anchor tag displaying our element. Next, we are going to copy the JavaScript path. Then go back to our code. We have the web element, which is the Shop Now button. That's it. It's important to convert to a web element from the JS executor.execute script method. At this point, we return the JavaScript path. Let me modify the path so it all shows up on the same screen. This is the path we just created. First line returns the shadow host from the original DOM. Second line is the shadow host from the nested shadow DOM. Third line is the Shop Now button. With the Shop Now button, we click. Let's run. The test passed. We see the button was clicked and the next page shows up with items. Thanks for watching and I'll see you in the next session. Thanks. In this session, we're going to look at a closed shadow DOM and answer the question, are we able to access a closed shadow DOM? Straight to the point, no, we're not able to access a closed shadow DOM. However, I'm going to show you why and also explain why we're not able to access a closed shadow DOM. Rob Dodson wrote an article introducing Shadow DOM. He uses this video player as an example. On the video player, we see a play button that turns into a pause button, time tracker, volume control, a way to make the screen full screen, and a way to download and have picture-in-picture. On the other hand, if I inspect the video player, we see a video tag with some nested source tags. Where are the other tags, such as playing the video button? Those other tags are hidden using a shadow DOM. Notice the breadcrumb does not show shadow root, but we can see how the browser implements shadow root by going to Settings, clicking the checkbox for Show User Agent Shadow DOM under the Elements tab. Close the settings, reload the page, and inspect the video player again. The video and nested source tags are still here. Now we also see shadow roots in the DOM and breadcrumb. You know how we could not find any tags for playing the video? Watch what happens when I expand the last div tag. We see play and those other media controls. That's encapsulation because they chose to hide the details. The checkbox Show User Agent Shadow DOM allowed us to analyze the encapsulation. There are two types of encapsulation mode, open and close. They have the same purpose, but the difference is an open shadow DOM mode allows us to access the shadow tree. However, a closed shadow DOM mode does not allow us to access the shadow tree, even if we use JavaScript. There is no way around it. This is a closed shadow DOM mode because the element shows shadow root user agent. Recall from the previous session, we can create our own JavaScript path or copy the JavaScript path. I am going to try and copy the JavaScript path by clicking right-click and copy JS path. And copy JS path is disabled. It does not highlight with the gray background. So let's go ahead and copy the JavaScript path for the shadow host, which is the video tag. Copy JS path, and go to the console. Clear it and paste. Hit enter. Now we see the video tag. If I maximize, we see the shadow root. Maximize one more time. And now we see the div tag that had the media controls. Access the shadow root after clicking the up arrow key, dot shadow root. Do you see null? Let's finish and write dot query selector. Open and closing in parentheses, two single quotes, and the div tag. Now I'm going to hit enter and we see a type error, uncaught type error. Cannot read property of null. That means we are trying to access a property of an object that is not defined. That's it for trying to access a closed shadow root, shadow DOM, shadow tree. Thanks for watching, and I will see you in the next session.
All Part 1 ebooks and PDF documents are free. Programming books for UFT. Programming books for Java. Here's the Selenium automation book. And TestNG. Subscribe to get notification of future videos. Don't forget to like, comment, and share.